Now see here, next topic is real depth and apparent depth of tank, and this type of the situation or this type of the observation you might have done in daily life. For example, in swimming pool, when you look at the swimming pool from the top, you will find its bottom appears to be raised. It means the swimming pool appears to be shallow, but actually actual depth you cannot see in that case. Similarly, if something is placed in the water, if you have taken a water in a glass and just you put a coin at the bottom, it appears to be raised. All these things are because of refraction of light. Now, let us see first example. Suppose there is a water in this here, and any object is lying over here. There is this we can have written object, this is O, and you are observing from this point, just normal viewing. Normally you are looking at the object. So, observer is here. Now, from the object we take two rays, one like this and one like this is here, and here at the point this interface we draw a normal, and we find after refraction it is going to this side and this is going to this side, and this is the actual normal viewing. This is normal to that point, or you can see one ray is taken from the object here like this. Now, when you produce these two rays, because they are diverging, so you cannot get the image over here. As you produce them backward, you will find the image is obtained here. So, actually the object is lying over here, but its image is seen at this point. So, the image is seen here, or you can say image is raised over here from the actual, or you can say it is, if it is a swimming pool, this is the bottom portion, it appears to be raised, and that will appear here, the shallow one. So, now let us take another example. Now, see another example of the real depth and apparent depth, or you can say actually previously we have done the normal viewing of the object lying inside the denser medium or inside the water. Now, we will be seeing here oblique viewing of the object. We are looking at the object obliquely. Suppose this is here water, and now object is lying somewhere here. We take one incident ray, it is here like this, just normally it goes without any refraction, and another ray like this. There is a normal at this point, this is angle of incidence I. After refraction, rays goes to this side, this is angle of refraction R, and observer is here looking at the object from this side here. So, when you produce this one, image is obtained somewhere here. So, actually the object is lying over here, but this image of this object is seen at this point. So, now we can calculate how much this object appears to be raised, or by what height. This we can take as A, this is B, and this line is here. If this is angle of incidence I, so this is also angle I equal to I, this is alternate angles, and this is R, so this also can be written as R. Now, we can write in triangle ABI, sin R is equal to AB upon here BI. Similarly, in another triangle ABO, so in triangle ABO we can write sin I is equal to AB upon BO. There are these two things here. Now, we can take from this one I and R we have got. According to Snell's law, we can calculate refractive index of this water. So, we can write refractive index of water, that is mu is equal to, mu W is equal to sin R upon sin I. Sin R upon sin I, that means here according to Snell's law, and also I have used here the principle of reversibility. So, when I am writing sin R upon sin I, that will be here AB upon BI upon AB upon BO. And now, we can solve this one. So, we will be getting here AB and AB will get cancelled. So, mu W is equal to BO upon BI. Now, see in this case BO upon BI, but if the angles are small, so we can take A and B are very close to each other. So, when A and B are very close to each other, so we can write BO is approximately equal to AO, and similarly BI is approximately equal to AI, and we can write mu W is equal to AO upon AI. AO is a real depth or the real position of the object. So, that can be written here real depth upon AI is the position which appear to be, that is called apparent depth. So, we can write here that is apparent depth. So, this is the refractive index is equal to real depth upon apparent depth. If we know this real depth and apparent depth, we can calculate also here IO. This is suppose x here. If it is x, so we can write here x is equal to AO minus AI, and when this is x is equal to AO minus AI, so we can write AO minus AI can be written here AO upon mu W, and now this AO upon mu W, and this can be written x is equal to AO into 1 minus 1 upon mu W. AO we can take, this is thickness of this medium T. So, we can write T into 1 minus 1 upon mu W. So, this is x is actually known as shift. By this distance, this object has shifted here. So, now we have seen real depth, apparent depth and shift. Now, see here, if you have got like a combination of the mediums like this, 2-3 mediums are here of the different thicknesses T1, T2, T3. Refractive indexes are mu1, mu2 and mu3. And some object is over here, then we can calculate total shift just by this thing is here x is equal to T1 into 1 minus 1 upon mu1 plus T2 into 1 minus 1 upon mu2 plus and T3 into 1 minus 1 upon mu3. So, by this way we can calculate the total shift here. Now, see here refraction effects at sunrise and sunset. So, actually here you must be knowing this thing is here, sun appears to be raised here slightly due to atmospheric refraction. So, before actual sunrise we can see the sun, and also we can see the sun after actual sunset. So, it means here this is happening only due to atmospheric refraction. So, now let us take example or let us understand how does it happen. Suppose this is the earth here, this line is horizon and this one is the by dotted line, this is the 2 layers of the atmosphere. I have taken sun is here below the horizon. Now, the sun's rays will be coming from rarer to denser medium. There is a slight refraction in that case here. So, now when the sun's rays comes here, it gets refract by the small angle. Then another layer also it gets refract because it is travelling from rarer to denser medium, and the observer here, observer of just this thing is here, the ray is coming like this. So, when this ray is produced backward, so the position of the sun is formed over here. So, actually sun is below the horizon, but for the observer it is seen at this point, that is the apparent position of the sun. So, actually before actual sunrise we can see the sun. Similarly, when sun sets and it is below the horizon, then also we can see the sun for some time due to atmospheric refraction, or you can say that this is the apparent position of the sun. Because of this, one is here delayed sunset and early sunrise, there is some time difference. So, actually there is a total time difference is here the 4 minutes, 2 minutes this side, 2 minutes this side. So, actually the day appears to be longer by the 4 minutes only due to this atmospheric refraction.